Most of the world's food comes from a small number of crops. Wheat, rice, maize. They feed billions. But only when rainfall is predictable, fertilizer is available, and soil hasn't already been pushed to its limits. There is another crop. It was never designed for ideal conditions. It grows in poor soil, without irrigation, without chemical inputs. It produces both calories and protein in a single harvest, precisely when staple crops begin to fail. For centuries, farmers depended on it as insurance against hunger. Modern agriculture moved past it, not because it was inefficient, but because it didn't perform best under controlled conditions. This is Bambara groundnut, a crop engineered by necessity and sidelined by a system built to reward predictability. Modern agriculture is built around a narrow definition of success: high yields under controlled conditions. Crops are selected for uniform growth, mechanized harvest, and predictable output. Anything that falls outside that model is labeled inefficient. But this system overlooks a different kind of performance. Bambara groundnut is a drought-tolerant legume that produces both protein and calories in poor soil, without irrigation or chemical inputs. For decades, research institutions such as the Food and Agriculture Organization of the United Nations have classified it as an underutilized crop, despite its proven role in food security across Africa. This is not the story of a crop that failed. It is the story of a crop that was never measured by the right standards. Bambara groundnut is a legume domesticated in Africa and grown for centuries as a complete food rather than a specialty crop. Unlike most staples, it produces both energy and protein in a single harvest. The plant flowers above ground, but forms its pods underground, protecting the developing food from heat and drought. It grows reliably in poor soils, without irrigation, fertilizer, or chemical inputs. Farmers valued it not for record yields, but for certainty. When rainfall was late or inconsistent, Bambara groundnut still produced food. When other crops failed, it reduced risk. This made it central to traditional farming systems that prioritize survival over surplus. Modern research bodies, such as the Food and Agriculture Organization of the United Nations, classify Bambara groundnut as an underutilized crop, despite its proven role in household food security. It was never bred for uniformity or machines. It was shaped by necessity. What defined its success was not how much it produced in ideal conditions, but how rarely it failed when conditions collapsed. That reliability is what separates Bambara groundnut from modern staple crops. Wheat, rice, and maize are bred to maximize output under stable conditions. They depend on timely rainfall, external inputs, and predictable seasons. When any of those variables break, yields collapse. Bambara groundnut operates under a different logic. It is structured to minimize failure rather than maximize surplus. Its deep root system accesses residual soil moisture. Its underground pod development shields the crop from heat stress and dry air. Even in low fertility soil, it completes its growth cycle. This means food arrives when other staples fall short. In practical terms, Bambara groundnut converts uncertainty into stability. It delivers calories comparable to cereals and protein comparable to legumes, without demanding the resources those crops require. While staple grains succeed in ideal years, Bambara succeeds in difficult ones. That difference is not reflected in yield charts, but it determines whether food systems endure disruption or collapse under pressure. That advantage disappears once crops are evaluated through modern agricultural metrics. Today, success is defined by uniform ripening, mechanized harvesting, and predictable yields per hectare. Bambara groundnut does not conform to these standards. Its pods mature unevenly underground, making mechanical harvest inefficient. Plants within the same field vary in timing and size, complicating large-scale processing. From a biological perspective, this diversity improves survival. From an industrial perspective, it creates friction. As agriculture became centralized, crops that could be planted, sprayed, harvested, and processed at scale were prioritized. Bambara groundnut was gradually excluded, not because it underperformed nutritionally or agronomically, but because it resisted standardization. Institutions, such as the Food and Agriculture Organization of the United Nations, describe it as an underutilized crop, a classification that reflects limited research investment rather than limited value. Once measurement tools favor uniformity, crops designed for resilience become invisible. Bambara groundnut was not outcompete in the field. It was outcompete on spreadsheets that measured efficiency but ignored failure, risk, and long-term stability. That exclusion is recent. Long before centralized agriculture, Bambara groundnut was integrated into farming systems designed around uncertainty. It was planted alongside cereals, root crops, and vegetables, not to replace them, but to stabilize food supply. When rains were inconsistent, Bambara still produced. When soils were exhausted from repeated planting, it remained viable. Farmers harvested it gradually, storing the dried seeds for months without spoilage. This made it especially valuable during the hunger season, when grain reserves were low and new crops were not yet ready. In many regions, it functioned as a reserve food, eaten when staples ran out or failed. Its role was practical, not symbolic. It reduced dependence on single crops and lowered the risk of total loss. These systems did not aim for maximum output. They aimed for continuity. Bambara groundnut fit that goal precisely. It delivered food across seasons, buffered shocks, and allowed households to survive variability without relying on external inputs or centralized supply chains. That stability did not protect Bambara groundnut from disappearance. As agriculture shifted towards centralized production, crops were selected based on their compatibility with industrial systems. Research funding followed cereals that could be improved through breeding, harvested mechanically, and traded internationally. Bambara groundnut did not fit those priorities. Its uneven maturity, underground pods, and localized varieties made it difficult to standardize. Colonial and post-colonial policies reinforced this shift, promoting export crops and high-yield staples over locally adapted foods. Over time, Bambara was labeled marginal, then ignored. Institutions such as the Food and Agriculture Organization of the United Nations categorize it as an underutilized or neglected crop, not because of poor performance in the field, but because of limited scientific investment. Once a crop falls outside research pipelines, it stops improving, adoption declines, and markets disappear. Bambara groundnut was not replaced by a superior food. It was displaced by crops that aligned better with global trade, mechanization, and simplified accounting. Its disappearance was administrative, not agricultural. That displacement shapes the present. Climate instability is increasing the frequency of crop failure, especially in regions already under stress. Rainfall patterns are less predictable, heat waves are more intense, and soil fertility continues to decline under repeated cultivation. Staple crops remain dependent on inputs that are becoming more expensive and less reliable. Bambara groundnut was built for these conditions. It completes its growth cycle with minimal water, tolerates poor soils, and produces food without external inputs. These traits are no longer historical advantages. They are current requirements. Yet modern food systems are not structured to reintroduce crops that fall outside dominant supply chains. Seed distribution, research, and markets remain aligned with a narrow set of staples. As a result, resilience is treated as an exception rather than a baseline. Bambara groundnut highlights a deeper mismatch between the problems agriculture now faces and the solutions it continues to prioritize. The crop still exists. The conditions it was designed for are expanding. What remains missing is a system willing to recognize value beyond short-term yield and standardized output. Understanding why Bambara groundnut was sidelined requires looking at a larger trend. Modern agriculture privileges a narrow set of crops that fit mechanized systems and global markets. Crops like wheat, rice, and maize dominate because they can be bred for uniformity, harvested by machine, and traded at scale. Other species with resilience traits, drought resistance, nutritional density, low input requirements, remain underutilized despite their potential contributions to food and nutritional security. Research shows that Bambara groundnut thrives in harsh environments and can produce reasonable yields with minimal inputs, yet it remains largely neglected in scientific inquiry and policy planning. Underutilized legumes like Bambara groundnut outperform many staples in climate resilience and adaptability, but limited research investment, underdeveloped markets, and cultural perceptions have restricted its broader adoption. This pattern extends to a wider group of neglected and underutilized crops that historically supported food systems, but were replaced by crops that fit industrial priorities rather than ecological or nutritional need. Recognizing this pattern highlights a systemic bias in how the value of crops is measured and points to missed opportunities for building more resilient food systems. Bambara groundnut is still grown quietly in the same places it always was, not because it failed, but because modern systems stopped paying attention. As climate stress increases and food systems become more fragile, crops like this reveal what was lost when resilience was removed from the equation. The future of food may not depend on new inventions, but on rediscovering what already works. If this story changed how you see food systems, subscribe to Nutrient Relics. These crops were never obsolete. They were overlooked.